Big O says which function, algorithm, or code is best. We learned that when it comes to good code, we're concerned about readability and scalability. And Big O allows us to measure the idea of scalable code. And why do we care? It's because there is no such thing as a free lunch. You save time and money for a company, you're a superstar. Knowing how much time your code takes, how much memory it uses, is very, very critical. Those are expensive things for a company or a product. Now, Big O is a very important concept that you won't find in your day-to-day job, but it's something that should always be in the back of your mind. And good developers and engineers always have this knowledge. That is why it is such a popular topic during interviews. Big O is used to describe how efficient we can run our code. It saves companies a lot of money if people they hire know how to write efficient code. And in this section, we learned about the idea of time complexity and space complexity, how we can use Big O to measure both things, but each one is a trade-off between the other. And Big O describes the upper bound of our estimates. We're always looking at the worst case scenario. We want to be pessimistic and say, what is the worst case scenario here with our code so we can be prepared when the time comes? Now, time complexity and space complexity. Time is how long it takes the algorithm to run, and space is the memory that is required by the algorithm. The important thing that we learned here is that Big O is about how you can scale. It doesn't necessarily mean that O(n) is better than O(n) squared, because scalability wasn't the only factor, right? Readability is something that we were concerned with as well. Sometimes readability maybe matters more than scalability. Maybe time complexity is less important than space complexity. And that's something that you want to be careful of now with this newfound knowledge. Premature optimization can be the root of all evil. It's a famous quote that a lot of developers know. Sometimes optimizing for time or space can negatively impact the readability of code. So if you're working at a young startup, for example, it might be more important for you to write code that's easy to ship and perhaps easy to understand later. Perhaps not take as much time to write the code and think about the code and its implications for long term, because maybe the startup has limited budget and needs things done fast. That doesn't mean startups don't care about Big O analysis. A great engineer at a startup or at a big company knows how to strike the right balance between runtime, space, and of course, readability. The thing to keep in mind is that data needs to be sufficiently big to talk about Big O. It's about scaling. If your function is linear time, but the input is always, let's say, 7 items, then the linear time algorithm might be better than the constant time algorithm. So it really depends on your situation. I introduced Big O here because we're going to be using it throughout this course. And as we learn more about data structures and algorithms, we're going to learn more about Big O and some other things we saw in this graph that we haven't talked about. But I hope you now look at a code differently, and you had a few aha moments throughout this section. It's certainly my favorite section and a great topic that really made me a better engineer once I learned this topic. So I hope it did for you as well. At the end of this all, you have a way to look at code differently. And when someone says, hey, how good is my code? You have a nice new way of looking at things and measuring things. I'll see you in the next one.